So last lesson, in lesson 1, we talked about functions and we got an introduction to functions. And we learned that there is one major rule of functions. Do you remember what that rule is? The rule is that each input can only have one output. So now in lesson 2, we're moving on to function notation. I can use function notation to evaluate functions. So what does that mean? If you remember, a function looks like an equation. And we're going to use that to evaluate functions. So a couple vocab words before we get started. Function notation is the way a function is written, and it looks like this. That is read as f of x. Now you may be thinking f times x, right? Because those parentheses, that is not multiplication. We read it as f of x. We'll get into that in a minute. Remember, input is the x, output is the y. So let's look down here. Function notation is used to help distinguish a function. So we have this equation y equals 9 minus 4x. Now, if you remember, y, is that our input or our output? Y is our output. X, that's our input. Which makes sense. We'll plug in an x value into our equation and see what our y value is. We plug in our input to get an output. Now we can rewrite this function using function notation. Function notation is so simple. Here is this equation now written in function notation. What's different? The only thing that's different is we no longer see a y and y equals. It's now f of x. These two are the same. F of x is the same as y. F of x is just another way of saying y. So, whereas y is our output, f of x will be our output as well. This means that when we plug in x, right? X is our input. It tells us x is going to be our input. So look down here. This image here tells us f is the name of the function. Sometimes you might see it as g of x. You may see it as h of x, right? This letter outside can change. That's fine. But in this case, f is the name of the function. X is the input. So if you see an x here, let me highlight that. If you see an x here, that means you'll see an x in your actual equation. So f is the name, x is the input, and this is read as f of x. And f of x is equivalent to, it's the same thing as y. So again, this is read as f of x. It's not multiplication. You may think it's multiplication because of the parentheses. It's not multiplication. It's read as f of x. So let's practice rewriting each function using function notation. Remember, f of x is the same as y. So if we have this equation y equals 6x plus 9, that's an equation. Let's rewrite it with function notation. All we would do is replace y with f of x. And then everything else stays the same, 6x plus 9. Let's try it again. Here we have y equals negative 1/2 x plus 3. If we were to write it using function notation, we replace the y with f of x, and everything else stays the same, negative 1/2 x plus 3. Last one, y equals 2x squared minus 4x plus 2. Let's rewrite that using function notation. Replace the y with f of x, because y is the same thing as f of x, just a different way of writing it. one's in function notation. And then 2x squared minus 4x plus 3 stays the same. So let's say I gave you this equation, y equals 3x minus 2. How would we rewrite this using function notation? We would write f of x. Remember, we replace y with f of x, and everything else stays the same, 3x minus 2. So now that we've practiced rewriting with function notation, we'll practice evaluating a function. All you have to do, directions are right here, simply plug in the value of the variable and solve the equation. So what does that mean? Let's take a look here. We have f of x equals 4x minus 2. That is our function. And they tell you x is equal to 3. So anywhere you see an x, you'll replace it with 3. So what does that look like? This is now going to be f of 3. Notice I replaced x with 3 because they told us x is equal to 3. Equals 4, and then I'll replace x with 3 minus 2. So notice anywhere there was an x, I replace it with 3. And now we can actually simplify this. So f of 3 is equal to, you don't have to do anything with the f of 3. You can leave that. We can leave that. 4 times 3 is 12 minus 2. And then 12 minus 2, f of 3 equals 10. So what does this mean? This means the input of 3, and I say 3 because look, our input goes there, has an output of 10. So our input of 3 has an output of 10. All we did was plug in for x to get our output. Same thing you would do if I asked you to evaluate an equation. Let's try here. We have the function m of x. Remember how I said that this variable, this letter outside can change? That's fine. All that means is this is a different function. It's not f of x. Now this one's m of x. The letter that's outside does not matter. What is the value of m of 4? Notice what used to be an x here is now a 4. That means wherever you see an x in your equation, we're going to replace it with 4. So let's do that. M of 4 equals negative 2 minus 3. Notice how there's an x there. So I'll replace the 3 with a 4. Why? Because they want m of 4 minus 6. So now we can simplify it. We'll leave the m of 4. We're looking for the output. So we can start here. Oops. Negative 3 times 4 is negative 12. So negative 2 minus 12 minus 6. And now we can combine these all. Negative 2 and negative 12 is negative 14. Negative 14 minus 6 gives you negative 20. So what does this mean? What is the output when the input is 4? The input of 4 has an output of negative 20. Input of 4 has an output of negative 20. All right, let's try one last one. This reads P of t equals t squared minus 3t. Find, how do we read this? We read that as P of negative 8. P of negative 8. So how will we figure out P of negative 8? Well, our input, what is our input? Negative 8. So that means we'll put negative 8 into our equation, into our function, and see what our output is. So let's try. P of negative 8 equals wherever you see a t, a t, right? And this time it's t. Wherever there's a t, you plug in -8. And again, it's okay that it's p of, doesn't matter what letter's out in front. So t squared minus 3t. We'll replace t with -8. So -8 squared minus 3 times -8. And now we'll leave this p of -8 and we'll simplify on the right-hand side. -8 squared means -8 times -8. A negative times a negative is a positive 64. 64. And then -3 times -8. Negative times a negative is a positive. 3 times 8 is 24. So p of -8 is equal to 64, and 24 gives you 88. So the input of -8 has an output of what? The input of -8 has an output of 88. So when you're working on these evaluating a function, what you're doing is they'll give you the input. Either they'll tell you x equals the number, or they'll actually write it out in function notation, m of, and whatever number is inside those parentheses is your input. And all you're doing is plugging it into your equation or your function and evaluating, simplifying, to get the output.